Today I'm going to be presenting on synthesizing novel analogs of curcumin for increased efficacy and stability in vitro and in vivo. Curcumin is the major active component in turmeric and has many medicinal properties such as anti-inflammatory, anti-carcinogenic, and pain-relieving properties. Despite this, pure curcumin has poor bioavailability due to the presence of the beta-diketone moiety and methylene groups. As a result, the goals of this study is to, number one, replace the beta-diketone group with a single ketone group using vanillin and acetone. Number two, utilize isosteres of the ketone group to synthesize an analog of the curcumin molecule using vanillin and dimethyl sulfoxide. And finally, synthesize an analog using a differently substituted benzaldehyde, in particular 4-fluorobenzaldehyde and acetone were used. For each goal, two aldol condensation reactions were carried out, which yielded an intermediate and target molecule. The reaction progress was monitored using thin layer chromatography. Purification was conducted by flash chromatography using a combi flash, and the structure of intermediates and target molecules were confirmed by NMR spectroscopy analysis. Scheme 1 shown on the slide corresponds to the synthetic scheme for goal 1, with compound 1A being the intermediate and target molecule 1 being the final molecule. Similarly, scheme 2 corresponds to the synthetic scheme for goal 2, with compound 2A being the intermediate and target molecule 2 being the final molecule. And then finally, scheme 3 corresponds to the synthetic scheme for goal 3, with compound 3A being the intermediate and target molecule 3 being the final molecule. Overall, for goal 1, compound 1A was successfully synthesized with 52.75% yield. Target molecule 1 was successfully synthesized with a less than 1% yield. The NMR spectra for target molecule 1 is shown on the screen, with the upfield peak around 4 ppm corresponding to the 6-methoxy hydrogens, and the downfield peak corresponding to the aromatic and alkene hydrogens. For goal 2, we were unsuccessful in synthesizing both compound 2A and target molecule 2, and the starting material was recovered. For goal 3, compound 3A was successfully synthesized with an 11.27% yield. The upfield peak corresponds to the 3-methyl hydrogens on the right-hand side of the molecule, and the downfield peaks correspond to the aromatic and alkene hydrogens. We are currently in the process of repurifying the product that is suspected to be target molecule 3. So overall, goal 1 was achieved, although low yields indicated the need to optimize the reaction. Goal 2 was unsuccessful, emphasizing the need to investigate alternative methods of synthesis to successfully incorporate the isostere. Goal 3 was successful in synthesizing the intermediate, and upon repurification, further analysis of the NMR spectrum obtained is required to confirm the synthesis of target molecule 3. Moving forward, we aim to enhance reaction yields by optimizing reaction conditions. We aim to explore methods of synthesis in order to achieve goal 2, and we aim to investigate a one-pot synthesis method in order to streamline the process. These are my references. Thank you so much.